Hi class, this is Mr. Morris. I'm out sick today, so I'm making a video for you guys. Make sure that you finish these notes and get through as much of the practice as you can. Tomorrow we will continue with practice a little bit, and then by the end of class we'll probably have a quiz. So make sure that you're good and ready for that. Alright, first thing we want to do, and if you were here yesterday, we already did this first part. You could skip ahead a few seconds to get down to the part that we still haven't done. Okay. Concentration. Is a measure to express quantitatively. That's an important word. Quantitatively means that it's numerical. Numbers or math. How much solute is dissolved in a solution or in the solvent. Molarity is a specific type of concentration. Molarity is a measure of concentration that gives the number of moles of solute dissolved in 1 liter of solution. Okay, then we have this word dilute. I want you to know 2 meanings of that. So as a verb, dilute means to add more solvent. But it also means low concentration. As an adjective, it means low concentration. So both of those words are important to know. Okay, to add more solvent, that's the verb. Low concentration is the adjective. This is probably the more important one for you to know. If we want to dilute something, we add more solvent, but if something is a dilute mixture, it has low concentration. Concentrated is the opposite of that. It has high concentration. It's a large concentration or high concentration. Molarity equation. So this is the first equation. Actually, this is really the only one that you need to do in this class for these notes. Molarity is the moles of solute divided by liters of solution. So we need to make sure that we have our units in terms of molarity, moles, liters, in order to solve problems. So if we're given grams of solute, we have to convert grams to moles by dividing by molar mass. It's probably better to use dimensional analysis. When in doubt, but we'll go back through that. If we want to convert from grams to moles, we're dividing by the molar mass, but we'll go back over how to do this with dimensional analysis to make sure we don't make mistakes. If you give milliliters of solution, so this is the solute is grams, our solution is given in milliliters of volume. We must convert milliliters to liters by dividing by 1,000. Once again, you can use dimensional analysis to figure this out. But make sure that you have, and actually let's just write it right up here. So this is the molarity equation. Let's go ahead and add a couple things. So 1,000 milliliters equals 1 liter. That's a useful piece of information that we're going to use. That's why we would divide by 1,000 if we have milliliters. And then molar mass and grams equals 1 mole. Okay. I'm going to work through the first example on this page. What's the molarity of a solution that is made with 34.5 grams of KCl? It gives us the molar mass of KCl and 500 milliliters of water. Okay. Start with asking for molarity. That's what I'm looking for. So I can use this equation up here, the molarity equation. Start with. Okay. It gives me 34.5 grams of KCl. That's important. Okay, so this is my mass of solute. It gives me molar mass. And then I have 500 milliliters of water. So what do you want to do? Just like we do with most equations, we're going to write down every variable that's in this equation. Capital M stands for molarity. Moles of solute. And liters of solution. Now, I don't have moles of solute, I have grams. I don't have liters of solution, I have milliliters. So it's important that I do my conversions. I'm looking for molarity, so I'm going to put a question mark there. Moles, I'm going to go 34.5 grams. And if you remember, dimensional analysis, we just multiply like that. And the way we decide how we set up the fraction is by putting the units that match this on the bottom of the next step. So I'm going to put grams down here and moles on the top. This is the number of grams in 1 mole, so I'm going to put 74.551 with grams and 1 with moles. Now I have liters of solution. Okay. I have 500 milliliters, so I need to do 500 milliliters times 1 milliliters on the bottom, and I want liters on the top. Up here we said there's 1,000 milliliters for every 1 liter, so I'm going to put 1,000 with milliliters, 1 with liters. If we put that in our calculator, 34.5 times 1 over 74.551, I get 0.4627 and so on. I want to keep 366, so that's going to be 0.463, 0.463. And I'm going to use the units that were on the top. Once again, down here we're going to do 500 times 1 over 1,000. The answer I get is 0.5, so I'm going to go ahead and put down 0.5 liters. Again, the units with those. We have a lot of room to work right here, but it's not difficult. So my equation is molarity equals moles of solute over liters of solution. Moles of solute over liters of solution. So M equals, we put 0.463 over 0.5. So 0.463 over 0.5. Alright, I get 0.96 or 926. And equals 0.926. But because I actually only have 1 sig fig in this answer, technically speaking, I want to round that to 1 sig fig. So I'm just going to keep that number. So molarity equals 0.9 molar. And that's it for the first example. Let's flip to the next page. Work through those. In this one, similar example, what's the molarity of a solution? made with 5.6 moles of KCl and 650 milliliters of water. Okay. And we can assume that that's going to be really close to the same volume. So what we're going to do is capital M, molarity is what I'm looking for. Okay. I want moles of solute, because that's our formula. Actually, let's write it up at the top right here just to make sure that we have a quick reference of our equation. Moles of solute over liters of solution. Okay, moles of solute. You see, I've already actually given moles. I don't have to convert this time because it's already moles. I'm just going to write 5.6 moles KCl. And then I have liters of solution. I have milliliters, so I'm going to convert that again. 650 milliliters. 1,000 milliliters goes on the bottom. 1 liter goes on the top. That's why we actually divide by 1,000, but this is another way of writing it. So we have 0.65 liters. Okay. The equation over here, molarity equals 5.6 over 0.65. I'm going to do that on my calculator. 5.6 over 0.65. I get 8.6. 8.6 molar. The way that you would read that. Okay, how many moles are in 3.5 liters of 2.5 molar solution? Okay. Well, this one, I'm not looking for molarity. I already have it. Molarity is 2.5. I'm looking for moles of solute and liters of solution. It's already in liters, so 3.5 liters. Okay. Everything is already in the right units to set up in my equation. So I can jump straight into the equation. Molarity equals moles over liters. I want to recommend that you go ahead and set this up as fractions so that you can cross multiply. I think it's easier for you guys to do that. So molarity equals moles over liters. Well, I have moles here. Moles is unknown, and then liters is 3.5. So I'm going to put 2.5 equals x over 3.5. Well, I'm going to go ahead and put a 1 here just so that I can make it easier for me to cross multiply. So I end up with 1 times x and 2.5 times 3.5. So 1 times x is x. X equals 2.5 times 3.5. X equals, put it down in the calculator, 2.5 times 3.5. Get 8.75, but we went around how many sig figs here? 2. So 8.75 rounds to 8.8. Always look back at the problem to see what your units are. We're looking for moles. And we'll put MOL right here. Approximate answer. Okay, last question, then you'll have some time to practice. This one asks how many liters are needed if you have this many grams KCl. It gives me the molar mass of KCl, so that's important, to make 3.0 molar solution. Okay, so our formula again is molarity equals moles of solute over liters of solution. Okay. In this case, I have grams of solute, so I need to go from grams to moles. 65.2 grams. Got grams here, so I'm going to put that on the bottom. 74.551 grams in 1 mole. And liters of solution. That's what I'm looking for. I'm looking for how many liters. And then up here, I have 3.0 molar. So 65.2 times 1 over 74.551. I get 0.875. All right, we want to set up our equation. Molarity equals moles. Oh, I should put my units here. Moles divided by liters. Well, liters is unknown, so I'm going to put X. Be careful. This is where mistakes are often made. Don't try to skip steps on this. Go ahead and cross multiply. 3.0 times X is 3.0X. And then 1 times 0.875 is 0.875. Then I want to divide by 3 to get rid of the 3. Get X by itself and solve for it. I need to do that on both sides. So X equals, and then we'll solve that. 0.875 over 3.0. 0.29166 repeating, so I want how many sig figs here? 0.2, so it's going to be 0.29. And my units, go back to this to remind yourself what units are. They're liters, 0.29 liters. That's it for the notes. Spend the rest of class working through the worksheet. I'll post an answer key for it, but remember, the goal of the worksheet is to prepare you for a quiz. So make sure that you don't just copy down answers. Work through the problems, refer to the answer key to help you check your work. And if you have any questions about it, you can try to send me an email. I'll try to check that at some point today. And otherwise, I can answer questions when I get back. Have a good day. Thank you.